Welcome once again to Sapima tutorial. Today we'll be looking at these problems on trigonometry. In this problem, I'll be teaching you how and when to make use of trigonometric identities to resolve right-angle triangles and when to use Pythagoras theorem. Trigonometric identities says that sine theta is equal to opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now, given a right-angled triangle, let's assume here is the given angle, whereas here is my right angle. The side facing the angle is always the opposite. The side touching the given angle is the adjacent. The side facing the right angle is hypotenuse. How do we know when to apply Pythagoras and trigonometry? Anytime you are given a problem and that problem has only to do with the sides of a right-angled triangle, then we use Pythagoras theorem to solve. For an instance, I have a right-angled triangle and I have my opposite, my adjacent, and my hypotenuse. No angle at all given, or the solution has nothing to do with the angle inside this right-angled triangle. Then we are restricting ourselves to Pythagoras theorem. But if at all my solution will touch the angle at all, anything will make me to go to the angle given either here or here, then I am using trigonometric identities. Next thing we consider is when do I use sine, cosine, and tangent. We make use of the mnemonic SOHCAHTOA to recall which of the three we use at a time. Now, given a triangle and that triangle has to do with the opposite of the angle and the hypotenuse. Look at opposite hypotenuse. We make use of sine, which goes for S. But if it has to do with the adjacent and the hypotenuse, we make use of cos, A and H, which goes for cos. If it has to do with the opposite and the adjacent, then we make use of the tangent because we have O and A present in the TOA of the SOHCAHTOA. Let's use this knowledge and simplify these three problems on the board. In this case, we are looking for x, we are looking for theta, and here we are looking for x. For the first one, I have a right-angled triangle and the longest side is missing. I have no business with the angles inside this right-angled triangle because I have these two sides present. Therefore, I'll be using Pythagoras theorem to solve this problem. Now my h is the longest side, which is x. X squared is equal to the adjacent, which is 3 raised to the power 2, and the opposite, which is 4 squared. Now we bring down our s squared equal to 3 squared will give me 9, 4 squared will give me 16. Adding the both, I will have 25. So s squared is equal to 25. But then to get my x, I will have to divide the both sides by the square root so that 2 and square root can cancel themselves. Then we have x. 25 square root of 25 will now give me 5. So the missing side is 5. Take note that we had no business at all with the angle. That is why we use the Pythagoras theorem. Considering the second problem, we are looking for this angle theta. Recall that I have told you that anytime the problem you are solving has to do with the angle of the right-angled triangle, then we use trigonometric identity. Then the next problem becomes, is this sine, cosine, or tangent? We go back. I have 6 and 7, the two sides of the right-angled triangle. Now 7 is facing the angle, therefore it is opposite. 6 is touching the angle and right angle, it is adjacent. So O and A can be found inside TOA. Therefore, I'll be using tan theta equal to opposite over adjacent. Now my theta is unknown, therefore I'll say tan theta is equal to opposite is 7 all over the adjacent is 6. To get my theta, I will have to divide the both sides by tan, and that is simply achieved by saying that theta is equal to tan inverse of 7 over 6. Make sure that when you want to press this in your calculator, you put it in a bracket. If not, you will achieve a very wrong answer. You can press your calculator now theta is equal to the tan inverse of 6/7 will give us 49.394 and other numbers proceeding. I can decide to approximate to the nearest degree. I will now have 49 degree approximately. Finally, I have another problem here. I have angle and one side present, and we are looking for the side, and we are looking for the longest side of this right angle. So I am going to be using trigonometric identity. Now, what do I have? Opposite and the hypotenuse. Therefore, I'll be making use of, I have opposite and hypotenuse. So it is sine theta equal to opposite over hypotenuse. Now, I'll say sine 30. My theta is 30 is equal to my opposite is 5 over x. The trigonometric identity of sine 30 is 1/2 equal to x. In my next video, we'll be considering the trigonometric identities of special angles 0, 30, 45, 60, and 90 degrees of sine, cosine, and tangent. These are special angles. We'll be considering it. But for now, let us import the trigonometric identities of sine 30, which is 1/2. At this point, you cross multiply. 1 times x will give me x. 2 times 5 will give me 10. So this is how we make application of trigonometric identities and Pythagoras theorem to resolve problems on right angled triangle. So with this, we come to the end of the class. Please, if this is the first time you are coming to my page, kindly consider following, liking my videos, and sharing my contents to your friends. Thank you very much.